Hello to everyone. I would like to present my report titled Surface Enhanced Raman Scattering of Biomolecules on Graphene Layers. And this work has been done at International Surface Enhanced Spectroscopy Lab at the Institute of Physics of National Academy of Sciences of Ukraine. Also, you can see the co-workers on this slide. And the outline of my today's presentation is following. First, again, I'll talk a little bit about SARS and a little bit about graphene and its application, and finally present my results about enhancement of Raman scattering by molecules adenine and thymine, which is two of the bases of DNA, which were observed on the graphene layers, and finally try to analyze the mechanism of enhancement and made conclusions. We heard a lot about SARS today, and I just reminded it is a surface-sensitive technique which results in enhancement of Raman scattering by molecules which were observed on the rough metal surfaces, and the enhancement would reach the almost 10 orders of magnitude, which is actually enough for single molecule detection. And the surface which commonly used in this technique is, for example, the noble metals like silver, gold, and copper. And at the bottom of the slide, you can see the surface which commonly used in this technique. This is clarity surface, which produced by Rynder company. And as has been already mentioned, SARS used to determine the vibrational properties of observed molecules, and finally for single molecule detection. In recent papers, it is a new abbreviation of which sounds like GERS, graphene enhanced Raman scattering, and which predicts the using graphene as a substrate for SARS. And it is not strange because graphene is widely used now in different fields of study, especially in nanotechnology, as like in medicine, in drug delivery system, in bioimaging, and also as a surface for biosensing and cancer therapy. As well, the oxidation form of graphene oxide is also widely used in technology, like to create a large screen display, a touch screen, and as well in catalysis. Characterization of graphene, considering that graphene has very unique properties, it is has excellent mechanical strength, exceptional electronic conductivity, and thermal conductivity, biocompatibility, and as the previous speaker mentioned, that electronic structure of graphene is uniquely captured by Raman spectroscopy, and in order to use some graphene, some samples, you first should check the electronic structure of it, and we can see from Raman spectra this material have a lot of defects or not, and finally investigate how much layers in your sample. In our experiments, we use graphene which were produced by using a chemical approach to exfoliate graphite microflakes, and it is production of Institute of Physical Chemistry in Kyiv. And actually, now you can see the result of experiment. This is a spectra. All spectra was registered by Rynder via Raman microscope, and this is a spectra of adenine, which was observed on a graphene, and the enhancement factor is actually not big, and it seeks for band at 184 centimeter to -1. And this is how its, I would say, aggregation of molecules look like of this adenine. And there is another spectrum of adenine as well, but it was observed on not graphene, but on graphene oxide. And here we got the enhancement factor more bigger than the previous one. It was 81 for a band at 1660 centimeter to -1. And actually, we wanted to compare because we work with different kind of type of carbon materials, and we compare our result with multiple carbon molecules, and we got the enhancement factor about 11. And then there is a table with assignments for every for different bands of this molecule, adenine, which were observed on graphene oxide, and then as well for multiple carbon molecules and graphene. And this is for another molecule, timine, which were observed on the graphene oxide. This is how it looks like with a microscope. And actually, we got to the two main mechanisms which works for SARS. It's electromagnetic enhancement and chemical one. Electromagnetic enhancement arises from the presence of surface plasmons on the substrate, and when molecule is close to this plasmon oscillation, you can receive this enhancement. And in order to investigate if in our case we have this enhancement mechanism, we measure the frequency dependence of dielectric permittivity and then calculated the real and imaginary parts of dielectric permittivity of graphene and the multiple carbon molecules. And this calculation shows that kind of theoretical calculation shows us that for graphene we have 2.5 only enhancement factor, and for multiple carbon molecules almost 100. Another mechanism is the chemical one, which involves charge transfer between a molecule, observed molecule, and the surface. And this actually is not a very big enhancement factor of it. It could reach 100 or less, much more smaller than 100. And also, what kind of nature of this mechanism? When the molecule is observed on the surface, it creates some chemical interaction, especially pipettaking interaction between p orbitals and of nuclear bases and the p electrons of graphene. And finally, the conclusions is that graphene and graphene oxide could be used as substrates for SARS of biomolecules, even though the factor is not so big. We got this enhancement, and the result is the factor of enhancement for molecules adenine and timine is in case of graphene is close to the 10, and graphene oxide is almost 80. And we can assume that preferable mechanism in our case is the chemical one. And I'd like to thank for financial support this kind of a project. And thank you for attention.
Question, please.
Thank you for this beautiful talk. I have a question concerning this enhancement of graphene. You compared also with graphite.
Graphite?
Yes. Or do you have any feeling of what happens if you switch from single layer graphene to double layer graphene to multi-layer and then to graphite?
Okay, if we're talking about our sample, actually it was not a perfect graphene as we used to know that what graphene is, but it was a kind of maybe 5 layers of graphene there, so we can imagine this situation that it's almost graphite, but.
And it was deposited on which kind of substrate?
It was a steel surface, metallic
okay.
surface. Yeah.
And how about the graphene oxide? Was also a layer or multi-layer or?
Oh, we prepare the solution, molecules with graphene and graphene oxide, and then deposited it on a steel surface, and then it's dried and measure it.
Thank you.
Someone, another question? No? Thank you again. Now we are finished our work and